Okay, so let f and g be two function such that, okay, limit x tends to a f of x and limit x tends to a g of x exist. Okay, then okay, so we have a limit of sum of two functions is sum of the limits, sum of the limits of the function, sum of the functions. Okay, that is, okay, so limit x tends to a f of x plus g of x. Okay, so which is equal to limit x tends to a f of x plus limit x tends to a g of x. Okay, also we have the difference. So limit of difference of two functions is the difference of the limits of the functions, that is limit x tends to a f of x minus g of x. Okay, which is equal to limit x tends to a f of x minus limit x tends to a g of x. Okay, okay, so this is the product. Okay, now let us see the quotient of two functions. Okay, so this is for the quotient of two functions. Okay, okay, this theorem for uh, any positive integer, for any positive integer n. Okay, uh, the limit x tends to a x to the power of n minus a to the power of n by x minus a is equal to n a to the power of n minus 1. Okay, so this is this theorem or the expression here which we have is true even if n is any rational number and a is positive. Okay, so let us prove it. Okay, proof for this. Now dividing x to the power of n minus a to the power of n by x minus a. So we see that, okay, x to the power of n minus a to the power of n is equal to x minus a, x to the power of n minus 1, x to the power of n minus 2 into a, and x to the power of n minus 3 into a square, okay, and x a to the power of n minus 2 plus a to the power of n minus 1. Okay, okay, so this limit x tends to a, x to the power of n minus a to the power of n by x minus a. Again, limit x tends to a, x to the power of n minus 1, x to the power of n minus 2 into a plus x to the power of n minus 3 a square, and x a to the power of n minus 2 plus a to the power of n minus 1. Now let us substitute x as a, okay, okay, and this will be a to the power of n minus 3 into a square, and this is a into
X.
a
A
to the power of n minus 2, right?
minus plus
And you have a to the power of n minus 1. Okay, so this would lead to uh, a to the power of n minus 1, okay, plus again you will have a to the power of n minus 1, and again a to the power of n minus 1, and a to the power of n minus 1, and a to the power of n minus 1. So these are n terms, right? So this will be n into a to the power of n minus 1. So we got, that is a limit as x tends to a is x to the power of n minus uh, x to the power of n minus a to the power of n by x minus a, which is equal to n into a to the power of n minus 1. Okay, so hence we have proved that. Okay, now let us evaluate. Let's evaluate limit x tends to 1, x to the power of 15 minus 1 by x to the power of 10 minus 1. Let us solve this now. Now, the limit we can take separately. Okay, so that would be limit x to 1, right, can be written as I'll multiply and divide by x minus 1. Yeah, so let us see that. So x for 15 minus 1 by x minus 1 divided by x to the power of 10 minus 1 by x minus 1. Yeah, so we got this. Further we can write like this. Now let us simplify. So this is 15 to 1 to the power of 14 n minus 1, okay, divided by, this is 10 1 to the power of 9, okay. So this will be 15 by 10, okay, which is equal to 3 by 2. So this will be the solution. So let us evaluate, that is limit x tends to 3 x square minus 9 by x minus 3. So that is a limit x tends to 3. Now if you see here, when I put x as 3, so this becomes 0 by 0 form, right? 0 by 0 form. So let us split it. So that is x plus 3 into x minus 3. Okay, so this is x minus 3. So these two gets cancelled. Okay, so leaving out to be limit x tends to 3, and for the function which is x plus 3, let us substitute x as 3 now. So you get 3 plus 3, which is 6. Okay. Okay, so now let us evaluate. Limit x tends to 1, x square minus 4x plus 3 by x square minus 3x plus 2. Now, as x tends to 1 for this limit of as x tends to 1, so this becomes 0 by 0, okay, which is an indeterminate form. Okay, so which is an indeterminate form when you put x is 1. So let us applying L'Hopital's rule. Okay, now let us find it. So that is limit x tends to 1. So differentiation of this will be 2x minus 4 divided by 2x minus 3. Now substitute x as 1. So this will be 2 minus 4 by 2 minus 3. So which is equal to 2. Okay. Okay. Now let us evaluate limit x tends to 0 sine 4x by sine 2x. Okay. Now limit, what I'll do is I'll multiply and divide by 4x. Okay, so sine 4x by 4x. Okay, I've done this. 4x multiplied and divided, and I have this also, sine 2x. I've done this. Okay, right now we know that this will be 1. Okay, and also divides by, this is also 1, as x tends to 0 and 4x also tends to 0, and 2x also tends to 0. So we get that result as 2. Okay, so let us evaluate. limit x tends to 0, tan x by x. Okay, let us find. So limit x tends to 0, uh, tan can be written as sine x by cos x. Okay, to 1 by x. Okay, so this again results to sine x by x. Okay, into limit x tends to 0, 1 by cos x. So uh, since we know sine x by x as limit x to 0 is 1,
Yes.
and when you put x is equal to 0, cos 0 is 1. So this will be 1. So limit x tends to 0, tan x by x is 1. Okay.
Yes, sir.
So let us evaluate the limit x tends to 0, sine 3x by 5x. Okay. So limit x tends to 0, sine 3x. Okay. This is 3 into 3. I multiply it. Okay. And this is 5x. Okay. Multiply and divide by 3.
Yes.
Okay. Let me take x on the other side. So x tends to 0, sine 3x by 3x into 3 by 5. Okay. So let us change x to 0 as 3x to 0. So this becomes limit 3x to 0. Now this is sine 3x by 3x and the constant which is 3 by 5. Okay. So 3 by 5 into 1. So this is 3 by 5. As we know that limit x tends to 0, sine x by x is equal to 1. So let us evaluate. That is limit x tends to 0, sine square 4x by x square. So limit x tends to 0, sine square 4x by, now this is x square. So I'll multiply and divide by 4 square. Okay. So I can put this together. So limit x tends to 0 and sine square 4x and 4 square x square into 4 square, which is 16. I'll keep it outside. Okay. Now this is 16 into, now sine 4x by 4x, right? This is what we are going to form. And this is whole square. Now limit x tends to 0, also 4x also tends to 0. So that is limit 4x tends to 0. Okay. Now this is 1 square, which is 1. So this will be 16. Okay, that's it. So let us evaluate. Limit as x tends to 2, x cube minus 3x minus 2 by 2x square minus 5x plus 2. Okay, so again, when you put x as 2, this tends to 0. Okay, that is x tends to 2, x cube minus 3x minus 2, and 2x square minus 5x plus 2. This becomes 0 by 0, which is an indeterminate form. Okay, so by applying L'Hopital rule, okay, so this would be limit x tends to 2, that is 3x square minus 3 by 4x minus 5. And then let us put x as 2. So you get as 2 minus 3 by 8 minus 5. Okay, so which is nothing but 9 by 3, which is 3. Okay, okay, so that's done.